primary circuit, which consists of the main power switches and an on and off switch for the unit connected to the facility's power supply. It also has a line compensator in it, which is a device usually wired to the auto transformer that automatically adjusts the power supply to the X-ray machine to 220 volts. The circuit breakers protect against short circuits and electric shock. The auto transformer is an adjustable transformer controlled by the KVP. Step-up transformer is used to increase the voltage from the auto transformer to the kilovoltage necessary for X-ray production. Timer circuit for the exposure timer is located in this section because it's easier to control a low voltage rather than a high one. It includes a synchronous timer and electric timer. Also an AEC device which serves the same role as a timer. The patient's body part of interest is the variable in determining when to terminate exposure. In the primary circuit, a voltage is determined by the auto transformer and applied to the primary side of the step-up transformer. A voltage is then selected from the auto transformer and applied to the filament circuit. And then the stage is set for the rest of the circuit, which is the secondary.
Go.
Next is the secondary circuit. It begins with the rest of the step-up transformer. Milliampere meter is placed here to monitor the X-ray tube current. Rectifiers are needed to convert AC to DC. It's made of two semiconducting crystals. One is a P-type and has an abundance of electron traps, and N-type has an abundance of freely moving electrons. One half of the AC cycle flows through the X-ray tube, and the other half, which would otherwise flow through the X-ray tube the wrong way, is suppressed. This type of waveform is called a half-wave rectifier. When 4 rectifiers are used, full wave rectification is achieved. Rectifiers are one-way valves and are necessary to route the electricity through the X-ray tube correctly. And now we'll move to the filament circle.
C.
The X-ray tube is in the secondary circuit and it is covered by a protective housing that provides solid, stable support for the tube. It also serves as an electrical insulator and thermal cushion for the tube. It also has a glass envelope that maintains a vacuum seal in the tube so no air gets in to prevent from arcing and damaging the tube. The tube consists of an anode and a cathode. The anode is the positive end of the tube. The purpose of the anode is to provide a target for electron interaction and to produce X-rays, and is an electrical thermal conductor. The anode contains the anode target for the electrons and an induction motor with a rotor and stator. Materials used in the anode are molybdenum for the disc phase, which has low thermal conductivity to minimize heat damage, tungsten for the target material, which has high melting point, high atomic number, to improve efficiency. Rhenium is added to the tungsten to increase thermal capacity and tensile strength. Induction motor could be a rotor or a stator. Stator is outside, made of electromagnetics, and rotor is on the inside, which is an iron core. Stators are energized and induce an electrical current in the rotor, which then turns the rotor to correct the magnetic field that was induced. Another stator does the same thing, which turns another rotor, and so on and so forth. The rotor turns continuously to try to orient the inducing magnetic fields. The cathode is the negative end of the tube. The purpose of the cathode is to provide the source of electrons needed for X-ray production. The cathode contains the filaments in the focusing cup. Materials used in the cathode are tungsten wire, which has a high melting point and does not vaporize easily, thorium, which is added to increase thermionic emission for boiling off electrons, and the focusing cup is made of nickel. And that is the X-ray tube. Oh wait, no. I have the filament circuit, and it draws electricity from the auto transformer, which then travels to the rheostat. The filament circuit consists of the rheostat, the step-down transformer, and the filaments. The rheostat is controlled by the MA selector, so the higher the milliamperage, the lower the resistance. The rheostat also controls the filament temperature and the rate at which electrons are boiled off of the filament. The exposure time works with the rheostat, and together they determine the quantity of the electrons boiled off of the filament. And then it goes to the step-down transformer, which increases the current by reducing the voltage that is applied to the filament. And then the final piece of the filament circuit is the filaments, and these are tiny coils of the wire that are housed in the cathode of the X-ray tube. These are typically two filaments represented on the control panel, which is called the large focal spot and the small focal spot. And that's the end of the